Hello, intrepid explorers. Welcome to the incredible Indonesian island of Sumatra, where a fantastic force of nature lies beneath the calm waters of Lake Toba. Did you know that there's a giant volcano hiding under the lake? It's so big that it could create an unbelievably powerful eruption that could change the world's climate for a long time. Today, we'll dive into the secrets of this underwater marvel and discover how scientists predict these cataclysmic events. Get ready for a mind-blowing experience. Indonesia, which is officially known as the Republic of Indonesia, is an archipelago located between the Indian and Pacific Oceans in Southeast Asia and Oceania. This nation's vast territory comprises over 17,000 islands, which includes the prominent Sumatra, Java, Sulawesi, parts of Borneo, and New Guinea. Sumatra is the third largest island in Indonesia, and located on this island is also the captivating Lake Toba, a hidden body of water which lies within the heart of a mighty supervolcano's crater. Besides this supervolcano, Indonesia's topography is largely shaped by the majestic presence of volcanoes, resulting from the convergence of the Eurasian and Indo-Australian tectonic plates along subduction zones. These volcanic wonders have left their mark on history through remarkable eruptions, such as the well-known Krakatoa eruption in 1883. Likewise, the colossal Lake Toba caldera was formed by an extraordinary supervolcanic eruption approximately 74,000 years ago, causing a prolonged period of volcanic winter lasting 6 years. The Pacific Ring of Fire. Indonesia's volcanoes hold a significant place within the Pacific Ring of Fire, also known as the Circum-Pacific Belt. This expansive region spans the periphery of the Pacific Ocean, where a multitude of volcanic eruptions and earthquakes continually occur. However, it is important to note that the Ring of Fire does not constitute a single, unified geological structure. Rather, volcanic activity and seismic events within its various sections occur independently of one another. Encompassing approximately 850 to 1,000 volcanoes, the Ring of Fire accounts for about 2/3 of the world's active volcanic activities. What is a volcano? There is no single standardized definition for a volcano. It can be defined based on individual vents, volcanic structures, or even volcanic fields. In some cases, the interiors of ancient volcanoes may have eroded, giving rise to separate subsurface magma chambers and forming distinct volcanoes. Moreover, many contemporary active volcanoes emerge as youthful parasitic cones from vents along the flanks of other volcanoes or within central craters. Certain volcanic cones amalgamate to form a collective volcano, such as the Tengger Caldera complex. While local communities might assign names to individual vents, precisely defining the active or dormant status of a volcano proves challenging. Indications of volcanic activity rely on historical records, radiocarbon dating, and geothermal observations. The dynamic nature of volcanoes in Indonesia and the intricate processes that shape their formation and eruption makes them an awe-inspiring geological phenomena. Mount Merapi. Interestingly, in Indonesian and various regional languages of the country, the term gunung is commonly used to refer to a mountain, including Mount Merapi. Hence, it may be referred to as Gunung Merapi in the local language. Since AD 1000, the enigmatic Kelut volcano has erupted over 30 times, with its largest eruption scoring an impressive 5 on the Volcanic Explosivity Index, VEI. Mount Merapi, on the other hand, has erupted more than 80 times and has been officially recognized as a volcano by the International Association of Volcanology and Chemistry of the Earth's interior since 1995, owing to its frequent volcanic activity. As of 2012, Indonesia boasts an astounding total of 127 active volcanoes, harboring a potential threat to those living within its volcanic range. Approximately 5 million individuals reside in areas deemed as danger zones, which means volcanic monitoring and disaster preparedness efforts has been prioritized. Volcanic eruptions causes tsunamis. There has been speculation about the potential link between the catastrophic earthquake and tsunami event that occurred on December 26, 2004, and subsequent volcanic eruptions. For instance, the eruption of Mount Sinabung in 2010, which had remained dormant since the 1600s, is considered as a possible example of such a triggering effect. The geography of Sumatra is characterized by the dominant presence of a mountain range known as the Bukit Barisan, meaning row of hills, stretching approximately 1,700 kilometers or 1,000 1,100 miles from the north to the south of the island. This majestic range was formed by the movement of the Australian tectonic plate. The plate's gradual convergence rate of 5.5 centimeters per year has given rise to significant earthquakes along the western side of Sumatra, including the devastating 2004 Sumatra-Andaman Islands earthquake. Beyond seismic events, this tectonic motion has also facilitated the creation of magma chambers beneath the island. Of the 35 active volcanoes in the region, one noteworthy volcano named Wei stands apart from the Sumatran mainland. The separation was caused by a substantial eruption that filled the lowland between Wei and the rest of the mainland with seawater during the Pleistocene epoch. The largest volcano in Sumatra is the formidable Toba supervolcano, which encompasses the iconic Lake Toba Square. This vast caldera was formed following a cataclysmic eruption and is estimated to have reached a staggering level 8 on the Volcanic Explosivity Index, VEI, signifying the highest intensity for a volcanic eruption. Within the mountain range of Bukit Barisan, the highest peak is Mount Kerinci, soaring to an elevation of 3,800 meters or 12,467 feet. On December 29, 1927, Anak Krakatoa, the child of Krakatoa volcano, emerged from the caldera formed in 1883 by the explosive volcanic eruption that obliterated the island of Krakatoa. The 1883 eruption of Krakatoa in the Sunda Strait went on from May 20th until October 21st, peaking on the late morning of August 27th, when over 70% of Krakatoa and its neighboring archipelago succumbed to destruction. This volcanic cataclysm, which collapsed into a caldera, ranks among the deadliest and most devastating volcanic events in documented history. The sound of the eruption reverberated a staggering 3,110 kilometers or 1,930 miles away. Reaching as far as Perth, Western Australia, and Rodrigues, near Mauritius. Reports claim that the volcanic sound wave circumnavigated the globe 7 times, resonating in 50 different locations worldwide. The eruption and the ensuing tsunamis resulted in at least 36,417 casualties. Additional seismic activity was reported in the days and weeks following the eruption, ceasing by February 1884. However, later investigations dismissed any reports beyond October 1883 by Roger Verbeek. The combined impact of pyroclastic flows, volcanic ash, and tsunamis triggered by the Krakatoa eruptions had devastating consequences for the region. Banten Province, located approximately 90 kilometers south of Krakatoa, was never repopulated and eventually reverted to jungle, now known as Ujung Kulon National Park. According to official Dutch records, the death toll from the eruptions amounted to 36,417 individuals. Ships as far away as South Africa experienced the reverberations of the tsunamis, and the bodies of victims were found floating in the ocean for months afterward. The tsunamis, caused by colossal pyroclastic flows entering the sea, displaced a substantial volume of seawater with each of the 4 major explosions. As a result, the town of Merak was ravaged by a towering 46-meter-high tsunami. The 1883 eruption of Krakatoa had far-reaching atmospheric effects, casting a gloomy shadow over the skies worldwide for years to come. Spectacular sunsets became a common sight across the globe, captivating the imagination of artists and observers alike. British artist William Scroft documented these vibrant sunsets through thousands of color sketches, capturing the red hues that adorned the skies halfway around the world from Krakatoa. The vividness of the sunsets caused alarm in various cities, with fire engines being summoned in places like New York, Poughkeepsie, and New Haven, as people mistook the fiery colors for actual fires. During the day, the eruption produced a remarkable optical phenomenon known as the Bishop's Ring, encircling the sun, while twilight witnessed a peculiar volcanic purple glow. In 2004, an astronomer proposed the notion that the red sky depicted in Edvard Munch's renowned painting, The Scream, 1893, was an accurate representation of the post-eruption sky in Norway. Weather enthusiasts of the time diligently tracked and mapped the effects of the eruption on the sky, dubbing the phenomenon the equatorial smoke stream. This early observation served as the initial identification of what we now know as the jet stream. For several years following the eruption, people reported sightings of a blue or even green-tinted moon. This was a result of the volcanic ash clouds containing particles of about 1 micrometer in size, which strongly scattered red light while allowing other colors to pass through. Consequently, Moonbeams passing through these ash-laden clouds appeared blue or green. Additionally, lavender-tinted suns and loosely formed clouds were observed. The Krakatoa eruption and tsunami. Since the cataclysmic eruption of 1883, Krakatoa has exhibited sporadic eruptive activity. The most recent significant event occurred in December 2018, when a large underwater collapse of the volcano triggered a devastating tsunami. The island of Krakatoa suffered extensive devastation on its northwest side, resulting in the loss of approximately two-thirds of its landmass. The area that was lost transformed into a shallow sea. Tragically, another eruption on December 22, 2018, triggered a deadly tsunami that struck on December 31, 2018. The tsunami reached heights of up to 5 meters and impacted over 300 kilometers, or 186 miles of coastline in Sumatra and Java. The disaster claimed the lives of 437 people, with 14,059 individuals sustaining serious injuries. Additionally, around 40,000 people were displaced. This eruption-induced tsunami stands as the second deadliest volcanic eruption of the 21st century thus far. Subsequent volcanic activity has been observed due to the relatively young age of the island. Krakatoa, along with other neighboring islands, remains a focal point of interest and extensive study for volcanologists, offering valuable insights into volcanic processes and their aftermath. Volcano cone collapse and rebuild. The potential hazard of volcano cone collapse and subsequent tsunami generation had been considered by scientists 6 years prior to the event. They had identified the western flank of the volcano as the most susceptible section for failure. Following the December 2018 eruption, it was confirmed that the southwest sector, including the summit, had collapsed during the event, triggering the tsunami on December 23rd. Satellite data and helicopter footage confirmed that the main conduit was erupting from beneath the water. The volcano experienced a significant reduction in volume, losing over two-thirds of its original size. Its elevation above sea level diminished from 338 meters, or 1,109 feet, to a mere 110 meters, or 360 feet. Satellite radar observations revealed that as late as 2019, the volcano was still changing its shape and form, with subsequent eruptions contributing to the reconstruction of its structure. The crater, which had initially opened up to the sea after the eruption, gradually rose above sea level. In May 2019, volcanic activity was observed around the newly formed crater as the volcano continued to grow in height, gradually restoring the areas destroyed in 2018. Since then, Krakatoa has experienced two additional minor eruptions, both in 2020. The underwater supervolcano eruption. While Krakatoa's volcanic activity is awe-inspiring, it pales in comparison to the immense supervolcano at Lake Toba. The eruption at Lake Toba approximately 74,000 years ago is regarded as one of the largest explosive eruptions in the Earth's history. Referred to as the Toba supervolcano eruption, it is believed to have caused a global volcanic winter lasting 6 to 10 years, potentially triggering a cooling episode lasting 1,000 years. The magnitude of such volcanic events emphasizes the profound impact that nature can wield on a global scale. In 1993, science journalist Ann Gibbons proposed the idea of a population bottleneck in human evolution around 73,000 years ago, suggesting that the Toba eruption played a role in causing it. Geologist Michael R. Rampino of New York University and volcanologist Stephen Self of the University of Hawaii supported this suggestion. Anthropologist Stanley H. Ambrose of the University of Illinois further developed the bottleneck theory in 1998. However, both the link between the volcano eruption and the global winter theories remains controversial. The youngest Toba supervolcanic eruption, which occurred approximately 74,000 years ago at the present location of Lake Toba in Indonesia, has been extensively studied. This eruption marked the final and largest event among 4 eruptions of the Toba caldera complex during the Quaternary period. With an estimated volcanic explosivity index, VEI, of 8, the highest rating on the scale, it contributed significantly to the formation of the massive caldera complex, measuring approximately 100 kilometers by 35 kilometers, 62 miles by 22 miles. Estimates of the eruptive volume of the supervolcano range from 2,000 cubic kilometers to 3,000 cubic kilometers, 480 cubic miles to 720 cubic miles. The most commonly cited estimate is around 2,800 cubic kilometers, 670 cubic miles. Approximately 800 cubic kilometers, 190 cubic miles, of this mass was deposited as ash fallout. This eruption mass was at least 12 times greater than that of the largest volcanic eruption in recent history. Wow! The 1815 eruption of Mount Tambora caused the year without a summer in 1816. However, the Toba eruption deposited a 15 centimeters, 6 inches, thick layer of ash over South Asia and spread volcanic ash across the Indian Ocean, Arabian Sea, and South China Sea. New research suggests that the Toba eruption may have been even larger than previously estimated, with a calculated eruption volume of up to 13,200 cubic kilometers. Some sources now classify it as a VEI-9 event. Toba supervolcano eruption in the glacial age. Geologist Michael R. Rampino and volcanologist Stephen Self argue that the Toba volcanic eruption caused a brief but dramatic cooling event, known as a volcanic winter, resulting in a drop in global mean surface temperature by 3 to 5 degrees Celsius, or 5.4 to 9.0 degrees Fahrenheit. Evidence from Greenland ice cores indicates a 1000-year period of low oxygen values and increased dust deposition immediately following the eruption, suggesting that the eruption may have triggered this prolonged period of cooler temperatures. Rampino and Self propose that global cooling was already underway prior to the eruption, but the Toba eruption acted as an additional factor that shifted the climate system from warm to cold states. However, Clive Oppenheimer rejects the hypothesis that the volcanic eruption triggered the last glaciation, although he agrees that it may have been responsible for a millennium of cool climate. According to Alan Robach, who has extensively studied nuclear winter scenarios, the Toba eruption did not directly lead to the onset of the last glacial period. However, computer simulations based on an estimated emission of 5.4 billion tons, 6 billion short tons, of sulfur dioxide suggest that a maximum global cooling of approximately 15 degrees Celsius, 27 degrees Fahrenheit, occurred for 3 years after the eruption, with lasting effects over several decades. This cooling would have had devastating consequences for life, as it would have caused the tree line and snow line to be around 3,000 meters, 9,800 feet, lower than usual. Despite varying estimates, scientists generally agree that a supervolcanic eruption of the magnitude of the Toba eruption would have resulted in extensive ash layers and the injection of noxious gases into the atmosphere, leading to worldwide effects on weather and climate. The Greenland ice core data also indicate an abrupt climate change around the time of the eruption, but there is no consensus as to whether the eruption directly caused the 1000-year cold period observed in Greenland or triggered the last glaciation. How can we predict future supervolcano eruptions? Moving forward, predicting the next supervolcanic eruption poses a significant challenge. An international team of geologists has investigated potential early warning signs of such catastrophic events, focusing on the volcano beneath Lake Toba. A recent study published in the Proceedings of the National Academy of Sciences, PNAS, provides insights into the time it took for the Toba supervolcano to accumulate its magma reservoir, leading up to its past super eruptions. Magma is what makes supervolcanoes particularly hazardous, as it builds up beneath the Earth's crust until the pressure becomes so immense that the entire system erupts explosively. The researchers have both good news and bad news to share. The good news is that they believe the next major super eruption from Toba is still approximately 600,000 years away. The bad news is that there won't be any distinct geological signs announcing its arrival, estimating the age-stored volume of magma beneath a volcano. In fact, we may not be aware when an eruption is approaching, as the buildup will be gradual and silent. To reach these conclusions, scientists from PNAS analyzed levels of uranium and lead in zircons, which are tiny crystals found in volcanic rocks. Previous research has shown that zircons can be used to estimate the volume of magma stored beneath volcanoes. One of the key characteristics of zircons is that they contain uranium within their structure, which decays into lead over time. By measuring the amount of uranium and lead in zircons using a mass spectrometer, the researchers can determine their age. The team examined zircons from various Toba eruptions, with the youngest zircon indicating the eruption date and older ones providing information about how magma had accumulated. The first super eruption occurred approximately 840,000 years ago after 1.4 million years of magma input, while the second super eruption at 75,000 years ago accumulated magma over a period of only 600,000 years. The researchers note that both eruptions were were of the same size. They explain that the second eruption built up magma more rapidly because over time, the magma heats up the continental crust surrounding the volcano, which helps keep the magma hot for longer. This creates a cyclical process of eruptions where the heating of the crust slows magma cooling and accelerates magma accumulation. Using this dating technique, the scientists estimate that around 320 cubic kilometers of magma could be present in the reservoir beneath Toba volcano today. While this wouldn't classify as a super eruption, which requires a volume greater than 1,000 cubic kilometers, it could still lead to significant global disturbances, albeit smaller than the massive 2,800 cubic kilometers expelled during Toba's previous major eruptions. When is the next supervolcano eruption? The researchers suggest that approximately 4 cubic kilometers of additional magma accumulates in Toba every 1,000 years. This implies that the next equivalent super eruption would occur in 600,000 years, though smaller eruptions could happen in the meantime. The same approach could also be applied to other supervolcanoes worldwide, such as Yellowstone in the United States. The study further highlights that no extreme events occur before a super eruption. According to the researchers, signs of an impending super eruption, such as a substantial increase in earthquakes or rapid ground uplift, may not be as evident as portrayed in disaster movies. At Toba volcano, everything is happening silently underground, and the analysis of the zircons now gives us an idea of what is to come, explains Luca Caricchi, one of the co-authors. Conclusion. Ultimately, this means that we can never be certain if or when the next supervolcanic eruption will occur. However, what we do know is that such a massive super eruption would have profound effects on humanity and the world we inhabit. If smaller eruptions can cause devastating tsunamis, not to mention completely melting vegetation, a supervolcano eruption not seen since 74,000 years ago might just be the apocalypse. What do you think? Knowing how uncertain it is to predict volcanic activity, would you ever consider living near one? Active or dormant? Tell us in the comments what you think about volcanoes and the tsunamis it causes. Don't forget to like, share, and subscribe for more natural marvels like this. Till next time.